Ever wondered how machine learning models make their decisions, how they learn from data? Let's dive into the fascinating world of empirical risk minimization, or ERM for short. ERM is a principle that guides the learning process of a machine learning model. It's like the compass guiding a ship on its journey, pointing it in the right direction. In the case of machine learning, that direction is towards minimizing the difference between the predicted outcomes and the actual outcomes. Think of it like this. Every time a model makes a prediction, it takes a leap of faith. But with ERM, we're trying to make sure that leap lands as close to the truth as possible. So why is this important? Well, the better the model is at minimizing this difference, the more accurate its predictions become. That's why understanding ERM is fundamental to understanding machine learning. Stay tuned as we delve deeper into this intriguing concept. Now that we have a basic understanding of ERM, let's delve deeper. Empirical risk minimization, or ERM, is a principle in machine learning that operates on a mathematical formulation. It uses a defined loss function, which essentially measures the discrepancy between the model's predictions and the actual data. This loss function is a crucial component of ERM. It's the gauge, the yardstick if you will, that ERM uses to assess how well a machine learning model is performing. The goal of ERM is to find the hypothesis that minimizes the average loss. Think of it as a trial and error method on a grand scale. The machine learning model generates a hypothesis, applies it to the data, and calculates the loss. If the loss is too high, the model tweaks the hypothesis and tries again, seeking that Goldilocks hypothesis. Not too much loss, not too little, but just right. So, in a nutshell, ERM is all about finding the hypothesis that produces the least amount of errors when applied to the data. But remember, it's not just about finding a hypothesis that works well with the data you have. It's about finding a hypothesis that will work well with new, unseen data. That's where the true power of machine learning lies, in its ability to predict and adapt. Now, you might be wondering where ERM fits into the broader machine learning landscape. Well, ERM is an inductive principle used for training machine learning models. It's one of the tools in a machine learning model's toolbox. It helps the model learn from the data, identify patterns, and make predictions. It's a crucial part of the machine learning process, driving the model's ability to learn and adapt. So as we dig deeper into ERM, we see that it's not just a simple principle. It's a complex and powerful tool that plays a vital role in machine learning. It's about trial and error, about learning and adapting, and ultimately about finding the least erroneous hypothesis. ERM is about finding the least erroneous hypothesis. So, how is ERM used in real-world machine learning applications? Well, the beauty of empirical risk minimization lies in its application, particularly in supervised learning scenarios. Supervised learning, as you may know, is where we have a pair of input and desired output data. We train our model using this data with the aim to make accurate predictions for new, unseen data. Here's where ERM steps in. It helps us choose the best model by minimizing the risk of errors on our training data. Imagine you're a chef trying to perfect a recipe. Each ingredient and step in the process can be thought of as parameters and algorithms in machine learning. ERM helps you tweak these elements to create a dish that hits the spot every single time. But just as too much salt can ruin a dish, there are limitations to ERM. One of the main issues is overfitting. This happens when your model is so well adjusted to your training data that it performs poorly on new, unseen data. It's like perfecting your dish for your taste buds, but failing to consider others might not share your palate. Another limitation is the assumption of independent and identically distributed data. ERM assumes that both the training and test data are drawn from the same distribution, but in the real world, this is often not the case. ERM is powerful, but not without its limitations. In the world of machine learning, understanding ERM can give you a significant edge. Let's recap the key takeaways. Empirical risk. Minimization is a guiding principle for machine learning models, aiming to minimize average loss. It's a trusted comrade in supervised learning, but it's not without its drawbacks. Overfitting can be a pain, and certain assumptions are necessary for it to work effectively. Next time you see a machine learning model in action, remember the role of ERM in its learning process.